All right, hell yeah. So this is the SAT, no calculator, 20 question, 25-minute math test. But what we're going to do is actually explain some of these. Person's like, can you teach me these? You know what I mean? So we're going to read them, word for word. We're going to go nice and slow. The graph shown represents the possible combinations of 3 credit and 4 credit classes a student can enroll in to complete an associate's degree program. Based on the graph, if a student enrolls in 8 3-credit classes, how many 4-credit classes will the student need to enroll in to complete this program? And then and then you got to reread it. So what the hell is the graph? The graph represents the possible combinations of 3 and 4 credit classes a student can enroll in. But yes, they can enroll, but it's necessary to complete their degree. So if you took 20 3-credit classes, you would have a degree. You would complete your degree. If you took 16 3-credit classes, well, now you need 3 4-credit classes. You know what I mean? So just if you want, look at this. So you have to take 20 classes over here. You know what I mean? So the most classes you would take is 20, because if you go up here to the 4-credit classes, you only have to take 15. But literally, if you take 15 classes, you graduated. Like, good for you. You know what I mean? And then over here, if you took 20 classes, you graduated. If you took 20 of these 3-credit classes. Okay, so with math, it's just like, well, just guess. The first thing to do is just guess. It's just like, well, how many classes am I going to have to take? Well, holy Toledo, I'm going to have to take 20 classes and maybe divided it by 4 years. So you're going to take 5 classes a year. Well, this is associate's degree. Does that mean it's like a 2-year program? Because it seems like you'd be taking more, you know what I mean? You're gonna take like 5 to 6 classes a semester. You know what I mean? So, but yeah. So if this was just 2 years, you would have to, in each year you'd have to take 10 classes, and then in each half a year you'd have to take 5 classes. Yeah, so that kind of works out to the 5 to 6 classes per semester. If that's what associate's degree means, I'm not too sure. But anyway, that's what math is. You know what I mean? What math is like, well, let's just guess. You know what I mean? And then, or they have a graph up here that's just like, well, the first piece of information on this graph is like, well, it looks like you need to take 20 classes to graduate. Cool. But if you just took 4-credit classes, you'd need to take 15. But now here's all the other points in between. And it's a linear scale. Because, and why is it linear? Because, okay, let's say you take 1 3-credit classes. Well, you just got 3 credits. You know what I mean? So if you take 20 of those, sorry, I wrote the 3. I don't know what you can see. But so if you take 20 3-credit classes, you're going to multiply. You're going to have 60 credits. Cool. But let's say you take 15 4-credit classes. You know what I mean? Now you're going to have the same 60 credits. You know what I mean? So at the end of the day, when you go to college, you just need just a number of credits. Once you get those, as long as they line up with your program, like your degree, then you graduate. You know what I mean? Check that box. Holy Toledo. But yeah. So at the end of the day, this is a perfect problem because the graph is kind of weird because it only shows a few of these points, but and I don't know. I mean, are these the only ones you could hit? Because that's the other thing is like, well, can't you? It looks like it's gonna go down 3, and then over 1, 2, 3, 4. You know what I mean? So yeah, so you're not gonna hit any other ones because if you went over, so this goes over 4. But if you only went over 2, you'd have to go up 1.5, and you can't take a half a credit. You know what I mean? So that is why that these are just total bullet points. You know what I mean? The graph can only hit these points because you can't take a fraction of a credit. There's no class that says, hey, we're just going to give you half of a credit for this class. And so that's the reason for these points. Okay, now what's the question? Based on the graph, if a student enrolls in 8, all right, and then we can already do this mathematically, because if you take 8 3-credit classes, you're going to have 24 credits. And now it says, hey, how many 4-credit classes will you need to complete the program? Well, we already figured out that you need 60 credits total, so you just subtract these. And again, when you're doing math, I just do 60 minus 30. Like, just friggin' guess. It looks like you're going to have to take like 30, 30 more credits. You're halfway there. But you only took 24, so plus 6, so 36. That's kind of how I do that. Else, else you got to do this, and you might make a mistake. 4 out of 10, 6, and then 2 out of that's 36. So the guessing approach, that's actually what I'm most fascinated into teaching. So anyway, that's question 1, and now we're just moving on. And maybe, I don't know, maybe I could just do one question at a time, but we'll see. We'll see. I'll just take a nice little pause if that's a video or whatever. Okay, here we go. So question 2. The graph of a linear function, f, is shown. Which equation defines f? You know what I mean? So, the first equation you ever learn is just like, hey, that's x. And let's talk about this. Y is equal to x. It says that if you go over 1, you throw in a value of 1 of x. If x is equal to 1, well, guess what? Y is equal to 1. So let's say instead of getting an hourly wage, like $15 an hour, and then working 8 hours a day, you're just gonna get. That's not how we do money, and we just do money by giving you 1. You know what I mean? 1 what? I don't know. You make up the number, or you make up what the definition is. But at the end of the day, I'm going to give you 1, and then you're going to take that 1, put it in your bank account, and then if you work 2 days, you're going to have 2. Cool. So every day that you work, I'm going to give you 1. So this line is perfectly, you know what I mean, like and you're going to get no raises, you know what I mean. So obviously this line isn't representative of actual work, because at the end of a couple of years you'd be like, hell yeah, we're going to be like this, and then you're like, nope, we're going to get a little bit more, and then we're going to get a little bit more. It's still every day you're going to get that same amount, but so anyway. Linear functions, are half of physics. There's only a few. I don't know. I mean, it's 90% of physics. A linear relationship between things. So anyway, so this is the graph of x. And then just from math class, if this goes right through there. You know what I mean? The y-intercept, xy, if this goes through the y, it's just going to be x plus 1. Now, why is that? Because you can throw in 2 values here. That's why when I made a mistake on number 7, is because they already gave you the x and y. They say when x is 3 or, and y is 0, you know what I mean? Then find the function. Or they say, like, even here, like, so our function right here says that when x is 0, y is 1. Okay, cool. So, this is like, hey, you got a bonus. Like, yeah, after you work your first day of work, x is 1 day. We're gonna give you your you're gonna have 2. You're going to have 2 in your bank account, because just for getting hired, we're going to give you 1. We're going to give you a 1 day's wage just because we hired you, and then after you work 1 day, in your bank account, you'll see the number 2, and you work another day, you'll see the number 3, blah blah blah. But that is so. That's just kind of a couple ways of being like, well. Do you want to learn that this is just x plus 1 and this is the y-intercept? Or do you want to learn that if you throw in x is 0, what do you get? You get 1. So you got to be, so this y value over here is 1, and you got to throw in x is equal to 0, but then you still have to get up to this 1. And the only way you can do that is just by adding 1. You know what I mean? So So that's the same thing as if y is equal to x squared. You know, if you and that's like this. But if you want x squared to be up on the, so let's say, you know, if you wanted to be up here on the y-intercept of 1, that means that if you throw in x is 0, you still have to get that 1. But you throw in 0 in here, you get 0 squared. That's 0. But then you still have to add that 1. There's your y-intercept. Now, could we do the same thing? So we said that when x is 0, y is 1. Well, what about when y is 0? Well, that's over here. So when y is 0, x is negative 1. Now, does that make sense? So when y is 0, x plus 1, you're going to get this. So now you're going to get x is equal to negative 1 because you're going to move this to the other side. And so that works out. So our function, we just showed the two. The kind of the easiest 2 points to put in are x is equal to 0, y is equal to something, and then y is equal to 0, and then x is going to be equal to something. All right. So anyway, we did it, and you know what I mean. And your slope is, I don't know, It's good. Once you get a hang of this stuff, then you can be like, yeah, the equation of any linear line is mx plus b. You know what I mean? It can't be anything else. That's the crazy thing. So it's like, so in some of these SAT problems, they're like, hey, does this crazy function have how many solutions? 1, 0, or 2? Well, you first got to see if it's an x squared, and it's probably not, and then it's just a function of x. But I had one where it was just 5x on this side after you got like foiled it out, and then you had 5x on this side. So you could subtract, you could take this, subtract over here, and it was 5x plus 2. You know, and then you're just left with 2. So the only linear function that has no solution is a constant. And this would be just y is equal to 2. You throw in any x value, you're just going to get that, you know, that number on that line. But if you have anything anything different than a constant, I mean, you throw any variable whatsoever, x, any variable that's not just a number, that's not a constant, you're gonna have some line that will cross the x-intercept, and you're gonna have some, even if it goes this way real shallow, you know, it'll cross the x at some point. And that also means that this is kind of a moot point, because if this is y is equal to 2, a graph like this is x is equal to 2, and they usually don't do that to you. You know what I mean? If this is your graph, I think basically you would just flip it. I mean, if you're saying this is the x and this is the y, you might as well just flip it and say, forget that. No, this is the x and this is the y. We're just used to doing graphs like this, where now this is the constant too. Okay, so that's linear graphs. I mean, that's linear graphs in a nutshell, because you do have two scenarios where, yeah, you could have a linear graph that goes straight up and down, but that's kind of bizarre, because you're only going to have one. You know, it would just make sense to switch the x and y axis. So then any value of x you throw in from negative infinity to infinity, you will just get that constant. Where if you do it this way, there's only one value of x that you can put in, and then it's got multiple values from, you know, so it's nonsensical, a line that's like this. So the other graphs that are kind of you know, like half circles that do this, when they got two different, those are you know what I mean, definitely nonlinear. Okay, never mind, I'm just spewing words now. But anyway, so those are your two scenarios, linear function. And it's just y is equal to mx plus, you're going to have a slope. So even just here, oh, it looks like you're going to go over 1, up 1. So your slope is 1. You know what I mean? And then that's the other thing. Your slope is rise over run. And I think it's always go up first and then over, but we don't do that. That's the thing that's gonna mess you up, because the first thing it seems like you do is you go over and then up. But when you write it in as slope, it's always rise over run. I think people have heard this rise over run in their, so much in their whole life. But when you do write this equation, always remind yourself, rise over run. You know what I mean? It's not. No one ever says it run over rise for that reason. And if you did run over rise, that just means like probably, well, and you'd probably have to negative it. Negative run over rise, I think, is the perpendicular or something. But if you just switched the y and x coordinates, I think then you would have just run over rise is this line. Also, yeah. But I'd have to double check that. But anyway, it's rise over run. So anytime you're doing these, you know what I mean, just check yourself. Like even if you count it this way, I'm gonna go over 2 and then up 2. Cool. You went over 2, up 2, but still say that your rise was 2 and then your run was 2. So 2 over 2 is your slope. Okay, so that's question 2, and you know what I mean. That's real good, because now we know. I would spend a whole day. I love talking about linear equations. People don't talk about them enough, because 99% of physics is linear relationships. You know what I mean? Even if you have something that's like, you know what I mean, gravity is a function of distance squared, that's not linear, but then your constant out front, like once you actually get that crap in order, your constant out front is a linear. So once you got that stuff, you know what I mean, your gravitational constant is your constants are linear. So you can throw in whatever distance, whatever mass of the two objects, and I don't know. That's for another video or whatever. But anyway, so this is a slope of 1. So y is equal to mx plus b. You can do it that way, but slope of 1, or you can just see that this is x. But yeah, you got to throw the slope in. I think everyone knows the number in front of x is going to be the slope. So if you got a steep slope of 2, you know what I mean, 0.5 is just going to be like a lower slope, and then it goes through the y-intercept. But always check. You can always check yourself by, you know what I mean. Usually the first thing you do is throw x to 0, but throw y to 0. You know what I mean, and then bring the 1 over there. X is equal to negative 1, and that checks out. Okay, holy Toledo, you know what I mean? But this is good, because you're going to spend 10 to 15 minutes learning a problem, so let's move on. All right, the graph of the polynomial function. We'll probably do 3 of these, and then maybe we'll just do 3 and call it a video. You know what I mean? 25 minutes is probably a pretty good, I don't know, we'll see how much we do. All right, the graph of the polynomial function, f, where y is equal to f of x, has intercepts -6, and this is x, this is y, you know what I mean? -6, y is equal to 0, and 6, 0. Which of the following must be true? So now, just friggin' A and do this, you know what I mean? So your x is -6. 1, 2, 3, 4, 5, 6, whatever, blah, blah, blah. And then your y is 0, and then this is 6. Okay, so you can just do a quick rough guess. But I love this one, because this is like, you know, when I started to like relearn math again, you know what I mean? This is great, because this is either it's either constant. I mean, you could have y is equal to 0. You know how you said we had y is equal to 2? You know what I mean? This is just a line that's right here. So but they say they already say it's like a polynomial function. You know what I mean? But a polynomial is just, I mean, a polynomial is ax squared plus bx plus c is equal to 0. But it's also just ax plus c is equal to 0. I don't know. I mean, is this not a polynomial? Is a polynomial only when you have an x is x squared and more and greater? I mean, is a constant equal to 0? Is that not a polynomial? Is bx plus a constant? You know what I mean? This is why your y is equal to mx plus b, because here's the last 2 terms of your polynomial. Anyway, But they're kind of already giving it that, you know, hey, this is probably like, it's probably like this. I mean, it could be like this. But I'm just saying it could just be y is equal to 0. You know what I mean? But anyway, well, let's actually get this one right. So the graph of the polynomial function has which of the following must be true? Oh, okay. So when you have a function, so your function of x is equal to y. You know what I mean? So y is equal to, you know, like x squared or something. So you know, this notation, see how this is f of x? It's because you throw in a value. You know, hey, I worked 6 days, and oh, it looks like they stole money from me. You know what I mean? Let's say that's the function. But anyway, so this is like, hey, I worked this many days, you got to give me that much money. So let's see. So we'll just do it. So when x is -6, well, here's your x and here's your y. So when x is -6, it's going to be 0. So this one checks. When x is 6, well, it should be 0. So that one doesn't check. When x is -6, 6 that doesn't check. And then when x is 0, right here, when x is 0, your function's -6. Your function is -6. Now this is the only one that could. This could be true. You know what I mean? This is why, and I want to say this. I tried to take the SAT reading, and I'm so bad at it because I'm just like, what the hell? Where are you coming up with this stuff? You know what I mean? Like, where is your brain taking these words on this page and then coming up with a conclusion that's just totally abstract? It seems abstract to me. That's why I almost cried. Like, I couldn't get through the 1-hour test. I'll probably post it, you know what I mean, to be like, yeah, I don't know. But that's why I'm doing this, because it's just like, this is that tricky moment, you know what I mean, to be like, it says, which of the following must be true? Yes, this could be, it could definitely be a x squared, and it could go through this point. You know what I mean? You just have x squared minus 6, you know what I mean? You know, and then probably, you know, and then something to actually make these equal to what they do. You'd have to have a constant out here. But even that, you know, hey, back to this gravitational constant, you know what I mean? So let's say you did have x squared minus 6, you know what I mean? Well, that puts your y-intercept at -6. So if you do throw x is 0 squared minus 6 is equal to, and this is your y, yeah, y is equal to -6. Got it. That's the point there. But let's say you do throw in now 6, so now you'd have 6 squared minus 6 is equal to what? Well, this is 36 minus 6. It would have to be equal to 30, and we're not getting 30. We're getting 0. So that's the difference here. Is that you would have to have a constant out here to actually, and this constant would have to be a fraction or something to actually make these 3 points hit. And we could do that right now, and I think we should, you know what I mean? So we want x squared minus 6 is equal to y, and when we throw in x is equal to 6, so we got this constant, so when we get 6 squared, which is 36, minus 6, we want y to be 0. Okay, so perfect. So then we got c is equal to 6, I think you can just do it in one swoop. Bring the 6 over here and then divide by 36. So you have 6 over 36. So the only way this could be an x squared, well, it could be if y is equal to 6 over 36, or what the hell is that? 36 is, yeah, it is just 1/6. So yeah, you could have y is equal to 1/6 x squared minus 6. So this could be the function. So that function satisfies this, because if you throw in a -6, the negative kind of goes away. -6, -6, that's 36, times 1/6 is just 6. 6 minus 6 is equal to 0. Perfect. Hell yeah. So, and this is perfect. You know, just doing 2 of these problems. Tomorrow I'll do 2 more. You know, maybe I'll just do another page at a time. So there's 20 of these. But, you know, someone in the comments is just like, can you teach me this? Well, this is the teachable moments. You know what I mean? This is the teaching part. You're just like, oh, is this what you know about functions? And I think I'm gonna be done. Yeah, we got 5 minutes. So yeah. I'm probably not gonna say anything more, but just kind of bring it home. But I love doing this stuff because because sometimes I mean, let's say you just had x squared is equal to 566 x plus 2. Like, you know what I mean? What the hell does this even mean? Well, let's throw in 0. I always do the 0, 1, -1 approach. Throw in 0. So we got 0 over here is equal to 0 plus 2. 2. And then circle the biggest number. Cool. Now throw in 1. Now we're going to have 1 over here is equal to, well, 566. Just a big number. I mean, but we're going to have 568. So circle that one. Okay, now do -1. And now so this was 0, 1, and then we're going to do -1. So now we do -1 squared is just 1 again, but then we're going to have -566 plus 2. That's going to be -564. Now which number is bigger? This one. Okay, so even just right here, what you get is there is going to be a solution between 1 and -1. Yep. So if these cross paths, if you have something on one side, you know, so you don't even have to get all this crap to the same side. And even if you did, if you got x squared minus 566x minus 2 to one side is equal to 0. Same thing. You throw in 0, you're going to have -2 is equal to 0. This is the bigger one. You throw in 1, you're going to have 1 minus 556, so you're going to have -5, minus 2, so you're going to have -565 minus 2, -568. But you're going to have this is equal to 0, so this is still bigger. Now throw in -1. You're going to have 1 plus 566 minus 2. So you're going to have 5667 minus 2. You're going to have 565 is equal to 0. So this one's going to be bigger. And for whatever reason, I use this a lot, but you're going to have a solution between 1 and -1. Does that make sense? And it should make sense right here, because you just said if you threw in 0, you got 2. So we need to reduce the number. You know what I mean? And then, well, maybe you need to increase it. So we threw in 1, and no. This thing's exploding. You know, you throw in 10, holy Toledo, you get 100. Well, this might not be a good one. But you're going to have 2 solutions here. This is just a way to find one of the solutions, and we do know there's a solution between 1 and -1. So that's cool. But even just right here, we threw in 10, and now you got 100 minus... No. This explodes. Now you have 5,600, 5,000. You know what I mean? So your negative just gets real crazy. Oh, and I think we did this wrong. No. We're over here. These are for this one. Yeah, so if you throw in 10, you get negative 5,000, you know what I mean? 5,000 is equal to... So we're going in the wrong direction. This is getting real small. So anyway, so there's one of your solutions, and there's going to be 2, but at least it hones you in. All right, so I can't really finish this thought. That would be for more problems that I can figure out. But there you go. There's 25 minutes, 3 problems, kind of learn some math. And no, I like this. I like this because it gets it off my chest. And it's just like, hey, this is the way that I learn. And this is the way that I would teach. And it's just kind of fascinating. It's very fascinating to me. Alright, so thanks for joining me, and guess what? That's a video.